Hello, I'm Roman. Welcome back to the series of videos Neural Networks from Scratch in Golang, where we're using this book called Neural Networks from Scratch in Python, but we writing everything with the Golang. And I want to remind that I have another channel. I'm posting a video. Well, I'm trying to do this every week, but currently hopefully I can manage to publish a video once in 2 weeks. The last one was about switching to the NeoVim, why I did this, and maybe you need to do the same, maybe you don't. So you can find what were the reasons and what benefits you could have from trying to use this. Also, I have a Discord channel. I launched it last week, and there is a small uh, party, I would say. So we don't have enough people there yet, but from time to time we actually can be pretty active and discuss things around the tech coding and stuff. So regarding the book, I'm still on the chapter 18. I told you before that it will be the longest chapter I will spend time on this. Well, at first it's pretty big. The second one, it involves a lot of refactorings and changing. And before we can go to the next chapter, I actually had some technical depth from the previous parts. I had to adopt some things for the future. And there is a last thing I need to do is to prepare for the categorial for the model that predicts categories. And there is this hack I don't like. The proposition is to put it into the train. But I actually have an idea what I can do. Instead of, inserting this knowledge into the model object, I want to try to create a two special, activation layer and the loss function that will do this. I mean, the proposal here is to use forward method from the activation and the softmax function, but use this backward method in this special case. And there is, there is a special object you call the backward method, and then the main thing is to take the inputs and assign it to the activation layer. We take the inputs. I think if we take a look at the loss doesn't have loss has the inputs too. And how we can do this? And the difference between the normal backward and this one is call backward method going through all of the object but less than reserved order. So it kind of cuts one, I think. How would we do it in a normal way? We'll call the backward methods on the loss function, and here it's written in a way that the loss is the last object. And then we go for all of the layers. So it will start from loss is the separate object, and then we will go from the activation. But what we do here, we call this special backward method. We calculated the inputs, and we need to skip calling the backward method for actual loss function. And what I'm thinking, I don't have to skip, right? I can implement backward methods for this optimized activation function, the backward method, but it will do nothing. So probably, maybe that's actually the whole idea of what I can do. Okay, so let me have a to do. So how I can fix implement, how it's called, this one, right? So what I can do? Create two special activation and loss functions, structs. Forward func will, the forward func will pass calls into normal loss and what's called activation. So where is it? No, wait. Yeah, so this will pass calls into ends, right? So then we have backward. So we have two backward calls, one for this one. One for loss, first one, right? One for activation. Basically, what we need to do, I need to call backwards called optimized backwards, take the inputs and assign to activation the inputs and what's called new activation, in this case backwards do nothing. So it will be a call, but it will do nothing. And that should work, because if you take a look at the train methods, right? So how it should work with backwards. So we will have, where is it? Okay, this one. Yes, so we have the loss, we'll call the backward method. But this one will call this optimized version. And loss function, I think it has the inputs. So in that case, it will return the inputs like the final. So after application of the loss and the backward from the activation. So then there is a question how we can do this, right? We kind of should, for this specific case, we should kind of go into this step already. So instead of getting the D inputs, because how it works in the normal way, we get in the D inputs for the activation, and then we go for the next one, which will be the dense layer, and we take in the D inputs from the activation. But since we will assign, but basically this new loss or this new activation should return the inputs from this object. And that's it. And it can return it here, or it can return it nil, because the backward method for activation, which will be called here function, will be empty, and I wouldn't care if it will return the nil. So this is what I've been thinking. In order to do this, I will actually create another folder, because I have no idea where to put it. So we'll call it optimizations, right? Okay, so let's do it here. Optimizations, right? And what it should be activation softmax loss categorial. I think I should change this one, right? No, softmax loss, this one, right? Okay, we should move it. Optimization like this, right? Yes. So the package will be optimization, optimizations, categorial cross entropy loss because it's in the loss, right? Yeah, we need to import this. Okay, but let me check some. Okay. So what I'm going to do, I will have new activation, new loss, factory method to create tuple of objects because we want to use them in pair, and one backward implementation. Okay, so should I expose? No, I don't need to expose it outside of it, but okay, we should have two activation softmax loss. So the first one is what is it? Activation softmax, right? But how it will look like? I will place all the things here. Well, first, it won't be called side worlds. Um, optimized softmax activation. No, that I will think. So, but how it will look like? It will actually use the activation inside, and that will be activation softmax activation, and we will take it from there. So optimized. Okay, and basically what it does, it will call activation forwards, and will pass inputs is training, and that's it. So this is our proxy. I don't need this. Okay, for the backwards, since it's an activation function, I think I don't need this. Since it's an activation function, it means that, by the way, do I need to initialize it somehow? No. Since it's a backward method, we don't need to do anything because the main logic will be called on the first object, which will be the loss. So basically what I need to do is leave it empty. Then I'm doing this. Get the output. Okay, so for this we return in the activation get output. For the D input, this is the main part. Activation get the inputs. And the predictions, yeah, okay. So that works, all right? So it behaves as the normal activation function. Then we need, what was the second one? Categorial cross-entropy loss. Okay, so we copy this again, right? And we changing it. So what we have, and we have optimize. Now let's take here, yes, yes, no, no. And what we're doing? Well, first, we don't need this. We need an actual loss, which will be categorial cross-entropy loss. Then we, oh, okay, then we're doing this, optimize. Okay, for the forwards, what should I do? I need to do return loss, forwards, and we'll have the prediction targets, and that's it. For the backward, and this is where the interesting part begins. Activation. Loss. I need a way to share this object. I don't need this. I don't need this. All I need is the inputs that will be calculated during the backward method. And we don't need this. This is the interesting part. Then the question, okay, so for the activation, it's actually has to be fixed. Return last the inputs, right? What we need to do, we need to actually pass this optimization. So this one, right? We need to have a reference. Backward implementation, and we will do this. And I should have the same here. The thing is, make optimize categorial cross-entropy, and it will return optimized activation and optimize this one. So how that will work? So first, we have the activation, which is the optimized integral cross entropy. We have the activation, which is the activation softmax activation, right? Then we have the loss, which is the optimized. Then we assign the original loss, categorial CrossentropyLoss. Then we have the optimization, which is the activations of this one, right? And then we do backward implementation equals to this one, and same here, right? Activation. There's no field, the method. Optimize softmax activation, this one. And then we return. Okay, so it means here I will actually return backward implementation the inputs. This is how it should work in the end. But for the backward implementation, what I should do is to call this backward implementation and call backward method and pass d values and targets, which I need to re-implement. I'll call it targets at ends, right? Okay, and here I assume that the target has only one column. That's target teams. If equal one panic, target should have only one column, right? And then at targets at I0 and same here. Targets at I0. Let me think once again. For the for the activation, this one works as the softmax activation. We have the name, we have the forward method. We do not use the backward method because we won't do actual calculation. We have the get outputs from the activation, and the get the inputs will return the actual, this combined values from the two. And the get the inputs will be called during the backward path for the next one, right? Wait, but do we need to return the inputs here, right? No? Yes. Okay, it's not working as the... Okay, I think I need to Yeah, probably I will have some compilation errors. Let me check, because I need to implement all of this, right? And currently my optimized one, we have name forward backwards. It should have the D inputs, right? Func D in gets D inputs. Um, and the D inputs will be called to pass into the backward method of the activation, which is not used. So we can return nil here, and that should be okay. Loss, no. Loss interface, set layers. The next thing is I have this one, right? And that will do loss, loss set layers, right? What is the next thing? Layer interface. No, not the layer interface. Loss interface. In the inputs and regularization loss, right? Regularization needs this. Returns float 64, so we'll return loss regularization. Okay, that should work. I think maybe if I missed something. Factory. And this one is optimized backwards implementation. Kinda, that's it. Which one's created first, by the way? We need to do actually a backwards implementation, I think. Yeah, they should share it. And that means that once I will need to use it, which I think we'll do in a couple of seconds, there's model. It should work. Okay, so we need to create a data set this moment. So this one should be, I think the last one is the categorial that I didn't do. So let's run categorial model. Let's make it better. Okay, I will just copy paste this for now, but just to make the implementation faster. So we're using the spiral data, yes, 1K and 3 classes. run. Same here. So then we have the model. We have the first layer is 250. We have the regularization and yeah, have the regularized L2. Then we have the activation. This is the first layer. Then we need dropout. Okay. Add layer drop out layer. How I initialize the rate initialization and rate? Okay. Initialization 0.1. And I think that should be like this. No. Cannot call pointer method initialization on. Hmm. Like this. Okay, we have the dropout layer, then we have the second, and how many? 3 outputs, right? 3. Then we have the activation softmax, but it's not the case, right? Then we have the optimize implementation and what we call optimizations make, right? Okay, so we will have the activation and loss, right? And that means here I pass the, okay, I will name them L. We have the A. Activation, right? Then we have the loss. Can't use L. Optimize CategorialCrossentropyLoss as the loss interface value. Doesn't implement loss interface. Wrong type. Have. Oh, okay. Missed one thing. Where is this one? This one, right? Okay, that's. I missed this. Optimizer Adam generates learning rate equals to 0.05. I need to update current. Oh, and I had a decay. Okay. Decay is 5e minus 5. And we have the accuracy, and then we have the model data, training model 100, print every. So, okay, let's take a look. So I have the dense layer with L2, 2 by 512. Then I have the activation. Then I have the dropout layer with 10%. Then I have the dense layer with 512 and 3 outputs. And then I have these activation softmax optimized. Right? By the way, optimized. And then we go to the main. And here, models run. Wish me luck. Oh, incorrect dimensions. Okay. Categorial goal. Categorial goal. Where? Wait. Okay. Details, print teams predictions, and the targets. Oh. They okay, they will be the same for the categorial. Yeah, okay, that's my mistake. I think that's one part actually what just happened. Wow, wait, what? Print 10? Oh, print, sorry, teams. Okay, teams. Okay, so at this moment we have these values, right? But kind of, yeah, now I remember this problem, and this is the categorical accuracy, but I mean, if there is one output, like for the binary, then I can compare them, right? But if it's the categories, then we have to shift. Outs. Yeah, it returns just a boolean. So I mean, why I should have two category accuracy maybe this one categorial. This one, right? Compares predictions to the ground truth value. So if it's not the binary, and we have the two-dimensional for the ground truth, but I mean, why it's not the vice versa? Because at this moment for the categorical, I mean, for the binary, I will have uh, kind of column vector, and I will have the target values the same, and that will be actually just the integer values, and this is why I can't compare them. This is fine, but for the but for actual categories, I need to convert the predictions into array of classes, right? With the argmax, and then I will be able to compare. Okay, so I will, you know what I will do? Let me check the time. Okay, what I need to do for the next video to do. I implemented this, fix models, this one. Make two accuracy implementations. Current, what's called? Current categorial accuracy rename to binary categorial accuracy and make new one for category predictions. Prediction. Basically, that will what it will do: converts predictions into array of predicted classes, and only then compare it to target classes. And I mean, and this is why, well, in the binary, I will use the binary accuracy. In the categorial, I will use the categorial accuracy, and that will make more sense for me. So I will do it tomorrow. For now, I think that's enough. I think I have a very good progress with the optimization. I finally fixed this thing I didn't like this check. Well, we'll see if I actually implement it properly. But from the code organizational perspective, I like it much more. So thank you for watching, and I see you tomorrow. Bye-bye.